Hello and welcome to this video, which is about modeling an equation for modeling the best fit equation, or taking a scatter plot and building a model with that scatter plot. And the scatter plot is made from two quantitative variables. Okay, so let's talk about the model. Now the model is going to be built from this scatter plot. Okay, and basically there's big formulas that go along in building the model. Okay, but all the model is a straight line. The model is a straight line which cuts through these points that minimizes the distance between the point and the line. Okay, so it minimizes all these distances from the point to the line. So for example, this distance here, I could get it to click, it minimizes these distances. Okay, so it prevents something like this from happening. Okay, so you'd say, oh, well, I want a really good line, so I'm going to cut through, I want to go right through this line. Well, yeah, this distance right here that I just went through, this last point on 40 and 4.1, yeah, went through it, but look at how far all the other ones are. Okay, so while one point is really good, the rest of them are really bad. Okay, so what it wants to do is it wants to do this, so all these points. Okay, and basically your calculator is going to do most of the work for you. Okay, but you have to understand what the model is. So if the model is a straight line, we call this a linear equation or a linear function. Linear equation. If you remember, a linear equation from algebra class consists of two important things. One is the y-intercept, which is right here. This is the y-intercept. Okay, and the slope, which basically determines the steepness, or how fast the line falls, or how fast the line rises. Okay, so in algebra it was called y equals mx plus b, but in statistics we use different letters and notations for it. So we call it y hat equals b naught plus b1 times x. Okay, and we do call this line a predictor equation. That's another thing we could call it. We call it y hat. Okay, that's a y with a caret. Let me write this over here. Y with the little caret over it, and we denote that, and we usually call that y hat. Okay, so whenever you see y hat, we know you're talking about making predictions. And here, what would we be trying to predict? We always try to predict the y's using the x's. Okay, so in this case, I'd try to predict how much tread I'd have left after I've driven so many miles. Okay, so hopefully it should make some sense. So looking at this, if you remember the other way from, okay, I don't want to confuse it too much, but from algebra they call it y mx plus b, and look at the coefficient, which is the number to the left of x, that was always our slope. Okay, and the number that's just sitting out here is a constant, which was our y-intercept. So here it's the same thing, we just have it backwards. Okay, the term with the x is over here on the end, so our b1 is our slope now. This term here is just kind of sitting out here, this is our y-intercept. Okay, so this is our b naught, and what the slope tells us basically is how much tread is being used, okay, per every mile for 1 unit of x. Okay, and we're going to do a whole video on that, and you'll be really good at slope. You really have to understand the statistical definition of slope, not just rise over run. Most people, what's slope? Rise over run. Rise over run. Yes, it's rise over run, but in statistics we use context. Okay, it's how much y decreases or increases per unit x. Okay, so in this case it's how much tread in millimeters is decreasing per unit x, but our unit in x is miles. So how much tread decreased per mile? That's it. Very basic. Okay, so anyways, you see this, but how can we find it? How can we find this stuff? Okay, so basically there are formulas, and on your formula sheet you'll have formula sheet, but we're going to want to use our calculator to do it. And I'll show you the formulas real quick if you just want to verify. And I actually just did this video the whole way through, and I got done and it was all staticky. So this is my second time through. So anyways, let's just verify that I have the data in. Okay, so I have my miles in my list 1 and my tread in my list 2. So very good. So now what I want to do is, okay, as I already did, I want to clear that out. Let's look at the scatter plot. So I already have the data in there. So second y equals, okay, my plot 1's turned on. If you look here, that's the scatter plot, list 1 and list 2. So go review that if you're not sure, but I'm in a position where I could just zoom 9 it. Zoom 9, so that scatter plot kind of looks like these dots here. Now I want to put a line through it just like this thing, just like this line's through. So I want to do three things right there. I want to find my y-intercept and my slope, and I want to create a line in the calc to make my my statistical computations a little easier. Okay, so it's just like finding R. It's pretty much almost exactly finding R, just one little extra step. So if you remember that, that's stat. We want to arrow over to calc. We want to go to number 8, which is line reg. Okay, now here if you hit enter, you could find your y-intercept, your slope, your R, and your R squared, which will be a later video. So what we want to do is we want to create that line, and I want to put that line right here. See, these are your functions in your calculator. I just hit y equals. If you hit y equals once, that takes you to all your functions on your calculator. Okay, so what I want to do is I want to put y1 right here. So y1 is a variable, so I'm going to go to vars. That's short for variable. So vars, I want y vars, I want y variables. I'm going to arrow over to y variables. I want a function, so I'm going to hit the number 1, enter on number 1, and there's my y1. I hit that right there. Now hit it enter here with that y1 there. It's going to put the equation for this line into my y equals. Okay, so let's look. Let's see what's my and I didn't tell you earlier, I don't believe. Some books do it like this. Some books write it like a plus bx. Okay, our book doesn't, and the formula sheet doesn't. So just remember, a is your y-intercept and your b is your slope. Okay, so in this case, here's my equation, and I always write it in context, tread left, in millimeters, and I put a big hat over it, equals. Okay, so my y-intercept is first, which is 9.4, let's say 18. Okay, now look at your b. That's your slope. It's a negative there, which makes sense because this is a negative relationship. Okay, so it's minus 0.168. Okay, and this is miles driven. Okay, if you put x here, you have to put x equals miles driven, y hat equals tread left, or you could just put it like this. So this is my model, and we call this model a least square regression line. Least square regression line. You'll hear that a lot. Least square regression line. See this line right here? Well, what they do is they square it, just like finding the area. This one would be 0 because the line falls right on it. So these are all squares. The least, you find each square and you add them all up, and you want the least squares. Okay, so that's that. So now let's get into a little bit more interesting stuff. So I have this situation where somebody comes in and they says, okay, let's make a prediction. Let's go over here to 28. Let's go to 28. Okay, so if I drive 28,000 miles, how much tread do I think is left? Okay, that's why we call this a prediction line. Now I don't have any points that are 28. No points that are 28. I have, but I built this model. Okay, so if I put 28, which is an x value, into here, okay, if I put 28 into here, this is multiplication, so it would be 9.418 minus 0.168 times 28. That's going to give me that's going to put me right on this line right here, okay, which would be my prediction for 28,000 miles. Okay, so I'm going to show you how to do it on the calculator. Okay, so you don't have to actually do all this out. So you have two ways. See where it says table there? You can go second graph, okay, and okay, So let me just delete this, what's there already. So my x is what I want to put in there, and y1 is that's where my equation is. Just to show you, if you just hit y1 once, okay, 9.417, it's not even rounded, so that's good. If you arrow over here, it'll give you the rest of this equation. Okay, so what we want to do is ask our table to put 28 in and hit enter, and it'll tell us that's how much tread we should expect. Okay, so if you drive 28,000 miles, you could expect approximately 4.7248 tread left on your tire. Okay, so we made a prediction from a model that we built from a data of 1, 2, 3, 4, 5, 6, 7, 8 data points. Okay, now I do a different way, and it's more of an algebra way. If you remember from algebra class, if you had something, let's say this, 3x minus 2, and I said find f of 2. Okay, you guys should be pretty comfortable doing this. Now if I say f of 2, all I'm asking you to do is put 2 into this x. That's 3 times 2, which is 6, 6 minus 2, which is 4. So 3 times 2 minus 2, which is 4. So f of 2 equals 4. So it's the same concept, okay? So, but we're not dealing with f's. In this case, we're dealing with y1. So just like we found y1 before, hit vars, over to y-vars. We want function, enter on y1. Now y1's sitting there. Now I have some parentheses above the 8 and the 9. Hit the open parentheses. Let's go ahead and put 28. Close the parentheses. Now what this is going to do is it's going to take this 28 and stick it into that function and that y equals, and it's going to go ahead and spit out the same thing the table did. Okay, hit enter. And so what this means is if we drive, or if the car is driven 28,000 miles, we expect approximately 4.725, what's my units? Millimeters of tread on tire. That's the statistical way to say it. Okay, so I'm going to be doing a bunch more examples of that, building the model, prediction, finding the predictions. Okay, so this is just the first of probably many videos that are going to come in this chapter. So if I went too fast or you didn't catch everything, watch it again. Okay, we're also going to be doing this stuff in class. So thanks for watching and have a nice day.